Now they give me a molecule and I have to pretty much say how many stereoisomers I'm going to have of this molecule. Well, we have a handy dandy little formula, 2 to the n, in which I can easily calculate the number of stereoisomers. I should say the maximum number of stereoisomers. The formula doesn't work if you have a plane of symmetry. So, but this molecule right here doesn't have a plane of symmetry. When I actually look at the molecule and I want to actually calculate the n right here, normally we say that n is the number of chiral centers. I'm going to put chiral carbons in here. But if you happen to have a double bond that could be cis or trans, that's another form of stereochemistry. So if you have a double bond that could be cis or trans or E or Z, you can count it as a source of isomers in here. And I do have one double bond that could be cis or trans. But let's just start with the chiral carbons right here. Around the molecule, you look at this carbon at the bottom. It has 4 different things attached to it. There's a hydrogen that it's not drawn, but it's the 4th thing. This carbon at the top is also a chiral center. So I have 2 chiral centers, 2 chiral carbons in that molecule. This double bond at the bottom, it cannot be cis or trans because notice this carbon has the same substituents, 2 hydrogens. So it can neither be cis nor trans. Same thing with the double bond inside the ring. There's only one configuration. If you want to close a 5-member ring, the 2 carbons have to be on the same side of the double bond. This carbon at the top, however, notice that I have 2 different substituents on the left carbon of the double bond and 2 different substituents, a hydrogen and an ethyl, on the right side of the double bond. So that double bond right there could be cis or trans, and I can count that as a source of stereoisomers. So if you do the calculation, n comes to 3. And what is the cube of 2? Be careful when you answer that question because I've had plenty of students that have had it wrong. It's 8. So let's go ahead and let's just pretty much say right here, what kind of stereoisomers do we have? Well, first of all, start with the double bond. Let's say the double bond is cis. If your double bond is cis, your 2 chiral centers could be both of them R. One could be R and the other one S. And you have 2 possibilities, the RS and the SR. Or both of them could be S. If your double bond up here is trans, then you can have the same 4 possibilities for your chiral centers. You could have the RR, the RS, the SR, or both of them S. So you have 1, 2, 3, 4, 5, 6, 7, 8 possible stereoisomers in this molecule.